All right, we're going to be doing Unit 2, Lesson 2 notes. This is graphing logs and transformations. So what we're going to be doing is doing a quick review. So if you remember, y equals x squared. This is our quadratic. This is also our parent graph. So parent graph means it's starting, whoops, making sure I have my pen on, graphing right here. And the nice thing is the a value in front of x squared gives us our slope from our vertex. So this means we're going to go up one to the right one, up one to the left one, and we get our parabola. Not perfect, but at least you get the idea. So our next one, here we've got y equals x plus 1 squared plus 3. The first thing we're going to find is our vertex. This is written in vertex form, so we're going to be taking our opposite of positive 1. And our k, which is our y value, stays the same. And that's going to be our vertex. We're going to go to -1, up 3. And again, our a value right in front is still 1, so that means you're going to go up 1 to the right one and to the left one. And with this one, we can see, we describe how it has moved. We know that it has moved to the left 1, and it moved up 3. Okay, so again, we're going to find the vertex, opposite of what's inside the parentheses, and our y value stays the same. So 2 and up 4, there's your vertex. Now the a value is a -1. That just means, whoops, we're going to go down. My hand keeps hitting wrong buttons. Down one to the right one, down one to the left one. We can make it. We'll go like that. So this one has flipped. It is moved to the right 2 and up 4. Now, the reason we did this review is because we want to see how it has changed from our exponentials. They do pretty much the same. If you notice, if it's in the parentheses, this is moving it left and right, doing the opposite of the sign it is. And the number outside the parentheses is going to be doing it up and down. Very same thing that we're going to be doing here. So here you can easily do this on Desmos too. You just plug in y equals x squared, or you can always go 2 to the 0 power, we know is 1. And then 2 to the 1 is 2, and 2 to the second power is going to be 4. And it's going to move closer, and then it's going to move up very quickly. There's your parent graph. Now, when we move it to now the next one we're going to do y equals 2x minus 3. This just means that we are going to be moving it down 3. This just moved down 3. Same thing as what we did on the top. So we're going to take each of our individual points and we're going to move it down 3. So our first one was right there. Go down 1, 2, 3. This one was down here, 1, 2, 3. And again, you can see can move it. And we have our problem. Then if we go ahead, look on the next side, we're going to make a table with a log. Okay, now the easiest thing we could do is we're going to just put in some numbers. And if you did it to the, let me go back. Let me explain how I got those numbers. So what we're doing, and I always like having the y over here because then you get to change it around. 2 to the y equals x. So if I change it to exponential, and I did 2 to the 0, we know that would be 1. 2 to the first power would give me 2. 2 to the second power would give me 4. Whoops. Sorry, this should be a 1. And then 2 cubed will give me 4. 2 to the fourth will give me 16. If you did the other one, if you did it on the other one, let me see if I can get, I need to change this just a second. If we did it on Desmos, nice thing with Desmos is you could have done y equals 2 to the x, and then you could have got your table. 2, we can just keep going. And then when we do the log, we know that we just switched them, and we could have just switched it over. Inverse. Giving a little hint there. All right. Oops. And so we're going to graph it. So run to 1, it's 0. Run to 2, it's 1. 4, it's raising up to 2. And we're going to go this way. If we got close enough, it would show us. Okay. Why did we choose the numbers for x? These are going to be all multiples of 2. Just makes it a lot easier. They're all multiples of 2. Now, if we look at our graph, our domain, these are our x values, okay? They're never going to touch the 0. So the parentheses just means we're getting close to that 0, but we're never ever going to touch it. And it continues to the infinite side, okay? Now, with the range, this is the y values. And we can see it's going to go, no matter what y value we put in, it's going to go from negative infinity to positive infinity, or all real numbers. And if we switched it and did this one for our exponential, these would be flipped. This one does contain the point 1, 0. It is continuous, meaning it's not just made up of dots. Now, this one has a vertical asymptote at x equals 0, which means where x is 0, it's not going to touch it, but it's going to get close to it, but it's never really going to touch. And then our increasing, it's increasing from 0, and it's going to keep on increasing no matter what numbers we put in. And then how does this relate to our y equals 2 to the x? I showed you earlier, it's the inverse. It's just going to be the inverse. Okay. So now we're going to do this one. So 2 plus log 2 x minus 1. We can easily put this into a table. And I'm just going to I'm going to start with 2. Okay. And if we did that, well, let's just use Desmos for this one. Let's go ahead and put Desmos and do it as a table with this. We're going to get rid of this. We're going to go y equals 2 plus. Now, here's the tricky part. You have to go to the keyboard, click on functions, and you're going to go almost all the way to the bottom. Then go back up. We're going to do this log one, log a. It's going to be 2. Then the parentheses x minus, parentheses x minus 1. Get rid of those extra parentheses. And then we like using a table so we can start figuring it out. And if you notice, -2, -1, 0, 1 are all undefined because we were moving this one, the whole graph, one more to the right. That's what that -1 meant. We're moving it 2 to the right. And I'm just going to pick whole numbers. 2 and 3, those are perfect. 4, definitely not. 5 works out pretty good. And if I continue on, which I've already done, I'm going to do 9 and 17. It's going to give me some perfect numbers. And we're going to write those in. Whoops. Sorry about that. There we go. So 2, 3, whoops. Come on. 3, 4, 5, and 6. Whoops. Oh, I should have made sure my table was over. Those are actually the wrong numbers. Those are going to be below us. Actually, they are going to be, 2, 3, 5, 9, 17. And it's going to be 2, 3, 4, 5, and 6. And then we can just go ahead and graph this. Okay, so 2, 2. We won't be able to do all the points just because our graph is not big enough. And 5, 4. And if you looked at it, we know it's not going to pass the x equals 1. It's going to get close to it, but it's never really going to cross. And what is the transformation? It moved up 2 and to the right 1. And that's it for today's lesson.